right, let's go ahead and do the practice test for the conic sections unit, unit 16. So we're going to run through here and take a look at this. This says determine which direction the parabola opens. So we know this is a parabola, and then they want us to graph it and all the key features. So we've got to include the vertex, the focus, directrix, and endpoints of the lattice rectum. Just a good way to graph and show everybody we know what we're doing when we do a parabola. So the first thing we notice about this is y is squared. So I'm going to write down that this opens. It's going to open in the horizontal direction. Little counterintuitive. If you think if y was squared, it would open up or down, but it doesn't. It opens in the horizontal direction. And then the next thing we notice is that this is positive. So that means it opens to the right. So it opens horizontally, and it'll open to the right here. And then I'm going to grab this number right here. That number is 12, and it's also equal to 4a. And we need to know what a is in order to graph some of these important features. So that's going to imply that a is equal to 3. Now, the other thing we notice is we've got a plus 3 with the y, and we've got a minus 2 with the x. So we want to indicate where the vertex is. The vertex is, this is going to be x minus h. So in this case, we take the opposite of the number with the x. So this is going to be a 2. Y plus 3, we take the opposite of that number. So this is going to be a minus 3. So that's where the vertex is. So I'll come over here, and we're going to graph the vertex at 2, negative 3. So 2, negative 3 is where the vertex is. And we know it opens to the right, so it's going to be looking something like this. And knowing what a is, if a is 3, that's the distance from the vertex right here. I'll put a little v right there. From the vertex to the focus is going to have to be inside the curved part of the conic section. So I'm going to put an F there for focus. And then the directrix has got to be the other direction. Remember, it curves away from the directrix. So we're going to go 1, 2, 3. So I'll put a little dot right there. And then this is going to be the directrix. So this is the line x equals negative 1. We've got our focus right here, and I'm going to draw a little arrow to that. So that focus is going to be 2, negative 3. That's where the vertex. That's where the vertex is going to be. And then the focus would be right here. So we're going to go 1, 2, 3. So the focus would be at, let's see, that's going to be 2. And so 3 more, that would be 5. So 5, negative 3. And then we've got to have the endpoints of the lattice rectum. So the lattice rectum is 12 units long altogether. So whatever this number is here in the original equation, that's how long the lattice rectum is. We just need to go half of that in each direction. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put a point right there. 1, 2, 3, 4, 5, 6. So we're a little bit off the graph. That's totally okay. And then I'm going to draw the parabola. So the parabola is going to go something like this. It's going to run along here, hit that point, end point of the lattice rectum, come around here, hit that end point of the lattice rectum, and then it's going to head off in each direction. So let me just finish labeling a couple of things here. I've got the directrix, I've got the vertex, and I've got the focus right here. Endpoints of the lattice rectum, this would be 5. And then we're going to be up 3, so 5, 3. And then this is going to be 5. And we're down here. We went down another 6, so that's going to be at negative 9. Okay, so there's our graph fully labeled there. Let's come down here on this next one. Basically the same type of thing, but it's not in the right format. We've got to get it in that graph-friendly form of a parabola. So we're going to do this. We're going to write down x squared plus 8x. We've already got this stuff over there, but I'm going to save room to complete the square. So this is going to be 4y minus 8. They're already on separate sides. And then I'm going to take half of that middle coefficient. That's going to be a positive 4. I'm going to square that, add it to this side. So I've made a perfect square here, but I need to compensate on the other side as well. So I'm going to do plus 16 there. And then we've got x, perfect square of x, and plus 4, quantity squared. This is going to give us 4y and plus 8 once I combine those constants together. And then I need to factor out the 4. So whatever the number is in front of the y, we're going to factor that out. So this is going to be a y and then plus 2. So now we've got it in the right form. X is squared, so this is going to open. And in this case, again, this is positive, so this is going to open up. And then the vertex is going to be, opposite of the number with the x, so this is going to be negative 4, opposite of the number with the y, so this is going to be negative 2. And then the other thing I notice on this one is 4 is equal to 4a, So that means a is going to equal 1. So let's come over here, and we've got a vertex at -4, -2. So back 4 and down 2. We've got a vertex right there. And then it's going to open up, so we're going to go inside that curved part of the conic section. So I'm going to put this right here. That's going to be F. And we go 1 unit down here because A is 1. So this is going to be the directrix. So if this is down 2, this is going to be down 3. So that's going to be y equals -3. So there's our directrix. And I'm going to go ahead and graph this. Oh, we've got to do the endpoints of the lattice rectum before we can come up with the shape of this. The lattice rectum is 4 units long in total, so we're going to go 2 units on this side and 2 units on this side. And then I'm going to grab a different color so we can graph this. So it's going to look something like this. Come in here, hit that endpoint of the lattice rectum, hit the vertex, and then head off in this direction right here. So we've got each one of these points that are on there, and then we're going to go ahead and label here. So the focus is, if this was -4, -2, this is going to be -4, -1. The vertex, of course, is, let's see, -4, -2. And then we've got our directrix there. And then we've got the endpoints of the lattice rectum. This is -4, -1, so we're going to go 2 units this way. So that point right there would be -2, -1. And this point right here, we went 2 more units that direction, so that's going to be -6, -1. Okay, so we got all the points there. Let's come down and take a look at the last parts of this page. It says find the equation, and you'll notice that we don't have a coordinate axes here, so if it makes us more comfortable to draw one of those, probably wouldn't be a good idea. But we've got a focus and we've got a directrix. So we don't have a vertex on this one. We have the focus and we have the directrix. So let's see where this is. So 2, 4, so we're going to be going to the right and up just a little bit. So 2, and then 1, 2, 3, 4. There's the focus. And the directrix, let's see where that is. That's at x equals 5, so that would be 1, 2, 3. Okay, so we went 3 units more than 2, so here's our directrix. Okay, so that's x equals 5. So that means the vertex would have to be right in between here. So if this is 5 and this is 2, that means the vertex is right here, and the vertex would have to be right in between 2 and 5. So that's going to be about 3.5. All right, so the vertex is at 3.5. Totally okay to do a decimal there if you would like. If you want to write that as, let's see, what would that be? 7/2. 7/2, and then we're up 1, 2, 3, 4. Okay, so 3.5, 4 for the vertex. And we'll notice since the directrix is on the right side and the focus is on the left, then it's going to go like this. So this is a parabola that opens to the left, which means y is going to be squared. So that means we're going to have y minus k quantity squared equals, opens to the left, so this would be negative, whatever 4a ends up being, and then this is going to be x minus h. So we've got part of this. Let's do y minus 4 quantity squared. We'll figure out what the 4a is in just a second, but this is going to be x minus, we could do 3.5 or 7/2, so I'm going to do 7/2. Either way, that's fine. And then what we need here is we need to know what a is. Well, if this right here is 3.5, then that's 1.5 units from either one of those. So what we take from this is that a is equal to 1.5. And if a is equal to 1.5, then 4a is going to be 4 times 1.5, so that's going to end up being 6. So we're going to put a 6 right here. Okay, so opens to the left, and there we go. So I'm going to circle this, and we should be all set there. Okay, on number 4, it's really nice when they give us the vertex, because that just makes things a lot easier. So I'm going to roughly sketch where that is and kind of plan out. This is -2, -4, so it's going to be down here, and the focus is at -2, -8. So we've got a vertex right here, and we've got a focus that's down even further. So this is going to open down, so that means x is going to be squared here. So we're going to have an x minus h quantity squared. This opens down, so this is going to be a -4a, and then this is going to be y minus k. So let's just go ahead and fill out what we know so far. This is going to be x minus a minus 2, so this is a +2 quantity squared. I'll leave this minus right here. We'll come back and we'll fill this in just a second. And then this is going to be, let me make some space here. This is going to be a y minus minus 4, so that's going to be a plus 4. Now we just need to figure out what a is, and a is the distance from here to here, so that's a. And if this is at negative 4, and this is down here at negative 8, then a is equal to 4. So we're going to do 4a equals 4 times 4. So we're going to end up with a 16. So a is equal to 16. So we're going to put a 16 right here. So we've got, yeah, looks great. X plus 2 quantity squared, and then we've got the negative because it opens down, and then we've got y plus 4. So we're going to go ahead and put box that in, and we're all set to look at the next page. So same type of setup on this page. We've got an ellipse now, and we want to graph all the key features, center, vertices, and foci. So let's go ahead and take a look at this. The problem here is it's not in that graph-friendly form. So the first thing I need to do is I need to make this side equal to a 1. So we're going to divide both sides by 36. So we get x plus 1 quantity squared. These would divide, so I end up with a 9 right here. And then this would be y plus 5 quantity squared. This would be a 4, and that equals 1. So now we're in good shape. So now we have a center. So the center is going to be, x coordinate's going to be the opposite of whatever's with the x, so that's going to be a negative 1. And then opposite of this, so this is going to be a negative 5. So we've got a center at negative 1, negative 5. So negative 1, negative 5. There's where the center is. And then we're going to go in the x direction, the square root of 9. So we're going to do the square root of 9 ends up being 3. So in the x direction, we're going to go 1, 2, 3. So we're going to put a dot right there. In the other direction, 1, 2, 3, put a dot right there. In the y direction, we're going to go the square root of 4, so we end up going 2 units in each direction, 1, 2 here, and 1, 2 here. And then if you want to make a really good-looking ellipse, it's kind of nice to put a little box around it. You don't have to, but I'll put a couple here just to kind of guide me around here. So it's going to look like this, and then come around here and look like that. Okay, so that's what the ellipse looks like, but we need to label some other things here. We need to label the foci. And remember, this one's going to be big 1 squared minus little 1 squared equals c squared. So in this case, we just find whichever one's bigger. So this is going to be 9 minus 4, and that equals c squared. So we end up with a 5 over here. And let's see, c squared, so that means c is going to be equal to the square root of 5. So we need to go the square root of 5, which is, I think, roughly 2.2, along the major axis. So I'm going to go a little bit more than 2 in this direction, so there's going to be a focus right here, and a little bit more than 2 in this direction, so there's going to be a focus right here. So we've got our center, focus here, and we've got a vertex here, and we've got a vertex here. So we want to label these. So I'm going to change colors so that I can label these a little bit better. So again, the center right here, we've already got that one. The center is going to be at negative 1, negative 5. And then the vertices, those are pretty easy. So the vertice right here, the vertex right there, that one's going to be, it's still the same number of units below the x-axis, so that's going to be negative 5. And we went 3 units, so this is going to put us at 2. And then in the other direction, okay, that vertex is, we were at negative 1, negative 5, and we went 3 units that direction, so that should put us at negative 4. So negative 4, negative 5. And then we were at the center here, and we needed to move radical 5 this direction. So this focus is going to be negative 1 plus radical 5 comma negative 5, because notice all those y coordinates stay the same. And then this one over here, the focus on this end, that one's going to be negative 1 minus radical 5 comma negative 5. Now, I know that gets a little bit messy. Try and be as careful as you possibly can. But that's how we do that. So I'm going to come down here and take a look at the next one. On number 6 here, this is not in a graph-friendly form, but you can tell that this is an ellipse because we've got 2 squared variables on the same side. They're both positive, but they have different coefficients, different size coefficients. So we're going to make some room to complete the square. So I'm going to gather the x's together. So this is 4x squared minus 16x. I'm going to move some space over here, and I'm going to do the plus y squared, and then plus 6y. And then I'm going to move the 39 to the other side. If I add the 39 to the other side, it becomes positive 39. Okay, now I can complete the square on this one because it's already positive 1 as a coefficient in front of the squared term. On this one I need to do a little bit of work, so I'm going to write this. I'm going to write 4 parentheses. I'm going to factor this out. This would be minus 4x, save room. I'm going to go ahead and put this in parentheses, so this is going to be y squared plus 6y, save room to complete the square, and then 39. Now, if you can get to this row all in one step, that's totally fine. Next thing I'm going to do is I'm going to take half the middle coefficient, so that's a negative 2. I'm going to put a little circle around that because I'm going to use it again. I square this, so that's going to be a plus 4. But then I have to keep in mind that by adding 4 inside the parentheses, what I've really done here is I've added 16 on this side. So I'm going to compensate by adding 16 over on this side. We're going to do the same thing here. This is going to be a plus 3. That's half the middle coefficient. I'm going to put a plus 9 here. And because there's a 1 outside, it's still just adding 9. So I'm going to put a plus 9 there. And then we're going to rewrite this. So this is a 4 on the outside. This is a perfect square of that variable and that number, so this is x minus 2 quantity squared plus y plus 3 quantity squared. And then over on the other side, let's see what we end up with. This would be 25 and 39 plus 25. This is going to end up being 64. So we get 64 there. So we're almost there. We're now at the point where we were with this previous one, okay, not quite in graph-friendly form. So then let's take this and let's divide everything by 64. So divide by 64. And now we're going to be in a nice graph-friendly format. Those are going to cancel, so I end up with an x minus 2 quantity squared. That's going to be over 16. This is going to be plus y plus 3 quantity squared. This is going to be over 64 because there's nothing to cancel that with, and that equals a 1. Okay, so that means the vertex, so we'll come over here and make the vertex. The vertex is going to be at positive 2, negative 3. So positive 2, negative 3, over 2, down 3. There's our vertex. And then in the y direction, we're going to go 8 units. So we're going to go, let's see, 4 would be here, another 4 would be here. So this point, and I'm going to go ahead and label these while we're here because we know how this is going to look. This vertex is at 2, 5. And down here, we're going to go 8 units down. So this is we're at 3. So this would be 2, 4, 6, 8. So we're off the charts just a little bit, just down here at 2, negative 11. Because if this was 3 and I subtract negative 3 and I subtract another 8, that's going to put us at, so this other vertex is at 2, negative 11. So I've got that one labeled. And then in the x direction, we're going to go 4 units. So 1, 2, 3, 4, and 1, 2, 3, 4. So that puts it over here. Now, if I draw a little box around here, I might do a better job. No guarantees, but I might do a little better job of making this look right. So let's see how we do. We're going to come around here, hit that point, come around here, hit that point, come around here, hit that point, and come around, whoops, I'm going to do that one again. Okay, come around here, and then guide it around like that. Now, I will admit that that looks like crap, but it gets the job done. Okay, so we've got the vertices right here. We've got the center. I'm going to go ahead and label the center as, whoops, I put vertex right here. This is a center, okay? And then this is 2, negative 3. And then I need the foci. So the foci, I need to add these I need to subtract these. So remember, it's the big one, 64, minus the small one, equals c squared. So this is 48 equals c squared. Let's see, that is 4 times 3. So c is going to equal 4 radical 3. And the square root of 48, that is a little less than 7. So we're going to go about 7 units in each direction. So 1, 2, 3, 4, 5, 6, 7. So a little bit more. Oops, did I get that right? There's 6, there's 3. Yeah, so this is way out here. Oh, so a little bit less than 7. Yeah, so right there. So there's a focus. So I'm going to draw an arrow to that one right there. And then we're going to go 1, 2, 3, 4, 5, 6, 7. A little bit less than 7. So we're right there. Okay, that's the other focus. And what we were doing, again, notice that the x coordinates are always the same. So this is going to be a 2, something, and this is going to be a 2, something. we started at -3, and then we added 4 radical 3. We added radical 48. So this is going to be -3 plus 4 radical, oops, got to fit a 4 radical 3 in here, plus 4 radical 3 here. And this is going to be -3 minus 4 radical 3, okay? So we've got everything labeled there. And I do just want to make a quick comment about this. I labeled this one as a vertex to start off with. That's a pretty common thing when people are graphing. They do some parabolas and then they graph an ellipse. They might label this center as a vertex. And likewise, when we've done a bunch of ellipses and hyperbolas and circles and stuff, we might label the vertex on a parabola. We might label that as a center. Not a big deal. We just want to make sure in the end we've got them labeled right. Okay, let's come down and take a look at this and figure out what these equations are. So on this one, let's see. It doesn't give us the center, but we can narrow in on a couple things. So notice that the y coordinate is always the same on each one of these. That gives us a really good hint. So we're going to be up 7 from here. So if I go to a focus is at 7, 7. Okay, so I'm going to put this right here. So this is 7 and this is 7. So we're at 7, 7, and that's a focus. And -3, 7. So back 3 and 7. So that's a focus. We can find the center right now. The center on this one would have to be right in between the two of these. It's 10 from here to here. So that means it would have to be 5 from either direction. So that means we're going to be right here. Center is going to be there at 2. So the center is going to be at 2, 7. And then the vertices are at 15, 7. So way out here at 15. There's a vertex. And then the other vertex is at -11. So way down here at -11, we've got a vertex there. So it's got to go like this. This is the major axis runs horizontally. So that means the big one is going to go underneath the x. So let's go ahead and write this here. So this is going to look like x minus 2 quantity squared plus, because it's an ellipse, and this is going to be y minus 7 quantity squared. That's going to equal 1. And then all I have to do is I just have to figure out what numbers go underneath. Well, in the x direction, it's pretty easy because we're going from, this is 2 and this is 15. So that means the distance from here to here, okay, we'll call that the a, that's going to be 13, okay? We went from the center, which was at 2 as far as an x coordinate, to 15, so that was 13 units that we went that way. So underneath the x squared, we're going to put a 13 squared, which is 169. Now the only other thing that we need is, we just need to figure out what goes underneath here. Well, that would be the distance that we go up and down. That's going to be b, and remember, it's the big one squared, so we're going to do 13 squared, minus the little one, which is going to be b squared in this case, equals, and let's see, this would be c squared, and c is the distance from the center to the focus, which was from 2 to 7, so this distance right here is 5. So this should be 5 squared. So let's see what we got. We got 169 minus b squared equals 25. So I'm going to move that to the other side, and I get -b squared equals, if I subtract 169, I think I end up with 144, okay? -144. So we're looking at b squared equals 144. Take the square root of both sides. So we end up with b equals 12, which if I need, I could go ahead and do that. But what I really was after was just this right here. I was just after the b squared. So this is 144. So well, let me make that look like a 4. So I'll put a box around that right there, and then we're all set. Okay, let's take a look at number 8. On number 8, they give us the vertices. Okay, so notice that the x coordinates are all the same. So I'm going to go ahead and draw something here where we've got 2, 0. Okay, so we're over here. There's a vertex. And then we've got another vertex we're down 6. Okay, so there's another vertex. So 2, 0, 2, -6. That's enough to figure out where the center is. The center's got to be right in between the two of those. The center's got to have an x coordinate of 2. Between 0 and 6, -6, that would be -3. So we've got our center. That's good. And then it says the minor axis is 2 units in length. So that's a really good piece of information, because what that tells us is remember the major axis, the vertices are on the endpoints of the major axis. That means we only go over this far. So we've got an ellipse that looks like this. So what that tells us is we can figure out from this that A is equal to 3 because that's the distance from the center to a vertex. And we can figure out that B is equal to 1 because that's the distance from the center in the y direction. In the x direction. So this is going to be x minus 2 quantity squared plus y plus 3 quantity squared equals 1. And then we just need to figure out what goes underneath each one of these. In the y direction, we went 3 units, so we're going to square that, so that's going to be 9. And in the x direction, we only went 1, so we're going to square that, and we're going to put a 1, and there we go. Okay, let's take a look at the next page. Okay, starting with number 9, on this page we've got hyperbolas, so let's go ahead and take a look at this now. I suspect that if we multiplied the two of these together, we'd get 441. So when we're dividing here, we're going to divide by 441. 441. I'm going to grab my calculator really quickly, and I'm going to put in a fraction. I'm going to put in 49 divided by, don't need the divided by here. Come down on the bottom, 441. Yeah, we get 1/9. It goes in there 9 times, so great. This is x plus 2 quantity squared over 9, which means this one right here, the two of these would cancel into 49, so this is going to be y minus 5 quantity squared over 49. And then on this side, of course, we have a 1. Okay, so from this, we can look at it and we can tell that, hey, we've got a center. The center of this is going to be -2, 5. And it opens, opens in the x direction, so opens horizontally. Okay, opens to the left and to the right. Okay, so let's see what we've got here. We've got a center of -2, 5, so -2, 5, so right there, there's the center. And then we've got, we're going to go in the x direction, we're going to go 3, so 1, 2, 3. And 1, 2, 3, and I can go ahead and put those. I can put dots there because they are actual points on the hyperbola. In the y direction, we're going to go 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. So we're up here just a little bit off the graph. That's totally okay. And then down here, 2, 4, 6, and 7. That's going to put us down there. And then I'm just going to make a mark here, and we're going to make the fundamental rectangle. That's going to help us make the right shape and come up with the asymptotes. So I'm going to go ahead and draw some diagonal lines through here, make those dotted. Okay, so we're going to go from here to here, make those dotted. Okay, and then I'm going to draw what the hyperbola looks like right now. So this is a vertex, and that's a vertex. So it's going to run along this straight line, curve over here and hit this, and then come over here and hit the straight line again. So I'll put arrows on the ends there. Run along this straight line, curve over here. This branch looks like it's a little bit better than my last one. Come over here, and then straighten out, and we're going to put arrows on there. Okay, so we've got the important stuff graphed. We want to label it. So again, the center, which I'll just put an arrow right here, the center is at -2, 5. Okay, so there's where the center is. And then we've got a vertex over here. So I'm going to draw an arrow to a vertex. That vertex is, remember, it's going to have the same y coordinate. We just went 3 units this way. So the vertex is going to be 1, 5. We went 3 units this way. So this is going to be -5, 5. So that other vertex is at -5, 5. And then we've got to find the foci. Okay, so for the foci, the cool part is we just add the two of these together. So this is going to be a squared plus b squared equals c squared. So this is going to be 9 plus 49 equals c squared. So that's going to be 58 equals c squared. And then I think the interesting thing about 58 is when we take the square root, it doesn't simplify at all. So that's just going to be 58. So we start right here, and we're going to move radical 58 units to the right. And 58, that'd be between 7 and 8. So there's 3 here. 1, 2, 3, 4. So 4. a little bit more. So roughly about right there. So we've got a focus, and the coordinates of that would be, we started at -2, and then we added radical 58, and then comma 5. And then going the other direction, it's the same as this one right here, but we just went to the left. So this is going to be, let's see, there's 3 and then another 4. So this is going to be about right here, just a little bit more than 7. Whoops, up here. Make that in the right place. There we go. Okay. So that focus is, it's just the conjugate of this right here. So -2 minus radical 58, comma 5. Okay. All right, so we've got everything labeled and all that sort of stuff. The only thing that we haven't written down is what the asymptotes are. And the asymptotes are actually pretty cool. We could come back here and we could compute what the slopes are and all that sort of stuff. But remember, I went down 7. Okay, so I'm going to write that as -7. And then I went over here 3. So this is a slope right there. But the quick way to do this is to just grab whatever's with the y. So that's y minus 5 equals, and then we put a plus or minus. It's the square root of whatever's underneath the y. That goes on the top because that's the rise. Square root of whatever's underneath the x. So that's a 3, and that's the run. And then we do x plus 2. We put that on there, and we are all set to go. Okay, so these are the asymptotes. Okay, we want to have those drawn, and we want to have the equations for those, and then we want to have the important features labeled. All right, let's take a look at the next one. The next one, all we need to do is just divide by 16. So we'll divide by 16, and we end up with this. We end up with y plus 1 quantity squared over 16. This is going to be minus x minus 2 quantity squared, technically over 1, and then over here we have a 1. So let's see what we've got here. We have a center. Center is going to be at 2, 1. Yeah, 2, 1. Oh, -1. 2, -1. Yeah, there we go. 2, -1. And the y is positive, so this is going to open in an up and down direction. So I'm going to go to 2 and then -1. So 2 over -1 right here. Okay, and then in the y direction, we're going to go 4. 1, 2, 3, 4. So I'm going to put a little dot right there. 1, 2, 3, 4. Put a little dot right there. In the x direction, we're only going to go 1. Okay, so this is a really narrow fundamental rectangle. Okay, so it looks something like that. So the asymptotes, really steep. Okay, asymptotes really steep on that one. Okay, and if we were to draw the hyperbola, it's going to run along here. Whoops, let me change colors so we can tell the difference here. Run along here, hit this point right here, go back up, run along here, hit this point here, and then back along there. And then we'll put the arrows on there to indicate to everybody we know that that extends forever in both directions. I'm going to go ahead and write down what the asymptotes are. The asymptotes in this case, again, we grab whatever is with the y, so we're going to do y plus 1. If you want to put it in parentheses, that's great. And then we're going to put equals, plus or minus. On the top is the rise, so that's whatever's underneath the y. So that's going to be a 4. And on the bottom, that's going to be whatever's with the x. That's the run, so square root of this would be 1. And then this is going to be x minus 2. Okay, so we could clean that up just a little bit by putting this down as a 4. Okay, which we'll go ahead and do. And I just want to double check. So it goes through the right point. It goes through 2, -1. And this has a slope of 4. So there's our positive slope asymptote. And this has a slope of -4. So we're in good shape there. All right, so I'm going to go ahead and label the center here. So the center over here is labeled 2, -1. Remember, we went 4 units up, so that means the vertex is going to be at 2, 4 units up. That's going to be 3. And the vertex here is 2, we went 4 units straight down, so that's going to be -5. And then we need to find where the foci are, and we'll have this all wrapped up. So remember, it's going to be a squared plus b squared equals c squared. So this is radical 17. Whoops, radical 17 by the time I take the square root. Okay. So we're going to go up radical 17, which is a little bit more than 4. So if this was 4 to get up here, just a little bit more than 4. So I'm going to draw an arrow right there. So this focus is at 2, And then remember, we started at negative 1, so negative 1 plus radical 17. And then the other one down here, again, we'll just put it in there. So this focus would be at, let's see, it's 2 for all of the x-coordinates, and then again, kind of a conjugate here, negative 1 minus radical 17. Okay? All right, so we're in good shape there, and let's come down and take a look at the last couple. So we've got foci and we've got vertices. We don't have a center, but we can deal with that. So let's take a look here. We'll notice that each one of the y-coordinates is negative, so I'm going to draw something that looks about like this. So we're at 8, negative 4. So over here we're at 8, and then we're down 4, so that's going to be a focus. And then we're at negative 4, negative 4. So negative 4, negative 4. So we're down here. That's a focus. That is enough information to figure out where the x-coordinate of the center is and the y-coordinate of the center. Because if it's 12 from here to here, that means it's 6 to go right in the middle. So if I back up 6 units or go forward 6 units, that's going to put me at 2. So that means the x-coordinate of the center is going to be 2. So the center is going to be located at 2, comma, and it's got to be negative 4 because it's got to be on an even level with the two of those. Okay, and the fact that we go from here to here, and that's 6 units, that's going to tell us something about what goes underneath the x. Okay, so that's really helpful. So we know it opens in the x direction because it's going to have to curve around here somehow. So this is going to be x minus 2 quantity squared. Then we're going to do a minus y plus 4 quantity squared equals a 1. And then I just need to figure out what goes underneath each one of these. So if this is, take that back. We got to do the vertices here. Okay, but that 6 is going to be helpful here. So the vertices are at 7. So a vertex at 7 and a vertex at negative 3. Okay, so we're about right there. So what this means is we go 5 units in this direction. So 5 units in the x direction. That means we're going to take the 5 and we're going to square it. So this is going to be a 5 squared. So this is going to be a 25. And then the other thing that we notice is that from here to here is 5, but from here to here is 6. So that's C. So A in this case is 5. C in this case is 6. So we're going to do a squared plus b squared. So a squared plus b squared equals c squared. That's going to be 5 squared plus b squared equals 6 squared. So 25 plus b squared equals 36. So I'm going to go ahead and subtract the 25. So I get b squared equals 11. Okay, and all I need underneath here is just, I don't need to know what b is, I don't need to know what the asymptotes are or the fundamental rectangle or anything. So I'm just going to put 11 right there. And I'll put a box around that, and that right there is the answer. Okay, let's come over and take a look at this one. We've got vertices, and let's see where we've got these. Same x-coordinate for all this, and the y-coordinate's changing. So I'm going to draw something over here that looks something like this. We're going to go over 1, and then we go down 1. Okay, so there's a vertex, and then we go down 9, and there's another vertex. Okay, so if this is negative 1 and this is negative 9, that means it's 8 in between those. So I can cut that in half, and I can find the midpoint right here. I'd have to go up 4 and down 4, so that's going to be negative 5. So I know the y-coordinate of the vertex is going to be negative 5. So that means the center on this one is going to be 1 comma negative 5, so that's going to be really helpful. And if it's got a vertex like this, it opens up and down. Okay, so that means that the y is going to be positive. So I'm going to go ahead and start writing this. I'm going to write down y plus 5 quantity squared minus for the x. So this is going to be x minus 1 quantity squared, and that equals 1. And then I'll make that look like a minus, okay? And then I just need to figure out what numbers go underneath here. Well, if we figured out that this was 4 units to go from here to here, and that's in the y direction, we're going to square that, so this is going to be 16. Okay, so a is 4 in this case, we're going to square that, and then we just need to figure out what b is. So the other thing that we've got is we've got a focus is at 1, negative 10. So we've got a focus down here. So that means that from here to here, from the center down to the focus is 5 units, okay? So that means c is equal to 5. So we can do a squared plus b squared equals c squared. So that's going to be 16 plus b squared equals 25. So then I can do b squared equals, we're going to subtract the 16, so I end up with a 9. So I've got a 9 right here. And again, I don't have to find out what b is, I just need to know what b squared is. So got the equation right there. All right, let's check out the last side and see how we do. Okay, on this page, we've got a tough task. We've got to identify the conic section and write the equation in standard form. Now, we don't have to graph anything, but we do have to find some of the key features on here. And there's no axis on here, so that might be a little bit challenging sometimes. We like the pictures and we like the coordinates and the numbers in order to have this make sense. So let's go ahead and take a look at this. You'll notice that they are all on the same side, so that's good. We've got two squared variables. They're both positive. So it's got to be either an ellipse or a circle. But this one right here has a 4 as a coefficient. The x has a 1 as a coefficient. So this is an ellipse. Okay, so we're going to go ahead and circle ellipse. Remember, a parabola is the only one that has only one squared variable, so that'll be pretty easy to find. And then we've got to find all these things, or we've got to write NA. So knowing what it has and what it doesn't have, that's important. So we're going to go ahead and write down, let's see, we've got x squared. I'm going to collect these together. And then I'm going to save some room to complete the square, and I've got 4y squared then plus 40y. And then I'm going to go ahead and move that 4 to the other side. So I've got all the same things represented here. All I've done is just move them around. This one's all set to complete the square, but this one is not because I need to get rid of that 4. So I'm going to go ahead and put this in parentheses, x squared minus 4x. Save room to complete the square. I'm going to take out the 4, and be careful, especially if you have to take out a negative. So this is going to be a y squared plus 10y. Save room to complete the square, and then I've got a negative 4 over here. And let's see, I'm going to take half the middle coefficient, so that's going to be a negative 2. I'm going to keep track of that. Square that, so that's going to be a 4. So if I add 4 on this side, I better add 4 on this side. I'm going to take half this coefficient, which is going to be a positive 5. I'm going to square that, so that's a 25. And then when I multiply here, what I really did is I added 100 on this side, so I'm going to add 100 on this side. Okay, so now let's take a look at what we've got. We've got x minus, whoops, I'm going to change colors again. We've got x minus 2 quantity squared, and then plus 4 y plus 5 quantity squared. And then over on this side, the 4's cancel out, so we end up with 100. So if I divide both of these by 100, here's what's going to happen. Nothing's going to happen on that one because nothing cancels, but that's going to turn into a 1, which is what we want. And actually, I'm going to write it over here so I've got some room. So this is going to be a 1, and then this is going to be an x minus 2 quantity squared over 100, and this is going to be plus y plus 5. Make that look a little bit more like a y. This is going to be y plus 5, and then the 4 and the 100 cancel, so this is going to be a 25. Okay, so here's the right equation. Okay, that equation is what we're going to be working off. So it does have a center. We'll go ahead and indicate what the center is. The center in this case is 2 comma negative 5. Okay, so I'm just going to draw a little sketch right here to maybe help out. So we're going to be at 2 comma negative 5. So we're going to be about right there. So the center is at 2 comma negative 5. Okay, and then in the x direction, we're going to go 10 units. So if I go 10 units over here and 10 units over here, this is going to have me at 12 negative 5 for one vertex. And going 10 units that direction, that's going to have me at negative 8, negative 5. So we'll go ahead and indicate those on the vertices. So the vertices are, one's going to be at 12 comma negative 5, and the other one's going to be at negative 8 comma negative 5. Okay. Let's see, there's no directrix. Okay, so we're going to put NA. No lattice rectum, so we're going to put NA. Length of the major axis. This is an ellipse, so yeah, this is, so we went 10 units here and 10 units here, so the length of the major axis is going to be 20. There's not really a direction of opening, so we're going to put NA on that, and it doesn't have any asymptotes. So that means the only thing we need to fill out here is just find where the foci are. So remember, the foci are going to be in here, inside the curved part of the conic section. So I need to figure out where those are. And remember, that one is going to be big 1 squared minus little 1 squared. So we're going to do 100 minus 25 equals c squared. So that's going to be 75 equals c squared. So that means c is equal to, let's see, that's a 5 times a 5 times a 3. So that's going to be 5 radical 3. So from the center, we're going to go 5 radical 3 in this direction and 5 radical 3 in this direction. And again, it's only going to be the x coordinate that changes. So we're going to take the center and we're going to add and subtract that same amount. So this is going to be 2 plus 5 radical 3, stays negative 5 for the y coordinate. And the other one is going to be the conjugate of that, 2 minus 5 radical 3 comma negative 5. Okay, so we've got everything indicated here, whether it shows up or not. And let's come down and take a look at the next one. Okay, so on this one, the first thing we notice is we're scanning through this, only x is squared. So if only x is squared, it's got to be a parabola. Okay, and the direction of opening, we're going to take a second to figure that out because we've got to actually get this in the right form first. So I'm going to gather these together. So this is going to be x squared minus 6x. Move the other stuff to the other side. So this is going to be a negative 20y and then a plus 31. So we want to be careful with those things. And then we're going to take half the middle coefficient. So that's going to be a negative 3. Okay. And then we're going to square that. So that's going to be a plus 9. So when I add 9 on this side, I have to add 9 on this side. So then we've got, this is going to be x minus 3 quantity squared. And this is going to be negative 20y, and then this is going to be plus 40. And then I need to factor that out. So this is a negative 20. I need to see what that y is all by itself. So if I take the y, and then if I take out a 20, what that means is I've got a negative 2. So once I've got the equation, this gives me all the information I need to figure out this other stuff. So it doesn't have a center, so I'm going to put NA. But it does have a vertex. So the vertex is the opposite of whatever's with the x, opposite of whatever's with the y. So the vertex is 3, 2. So the vertex is at 3, 2. So if I were to graph where that is, so 1, 2, 3, and then up 2, so we're right here. So there's the vertex. And the fact that this is negative means it opens down. So it's going to go something like this. Okay, so it opens down, okay, because that's negative. And then I need the directrix, length of the lattice rectum. Okay, no major axis on this one, so that's going to be an NA. No asymptotes on this one. It does have a focus, so we'll need to find that. So let's go ahead and see what we got going on here. Let's see. Finding foci on a parabola is a lot easier because we just take this number, 20, and that's the same as 4a. So what that means is that a is equal to 5. So if we know where the vertex is, we just need to go up 5 this direction, and we need to go down 5 this direction. So going up 5 in this direction, that's going to give us our directrix. So remember, if this is 3, 2, we're just going to go up 5. So that means this is going to be y equals 7. And then if we go down here, this is going to mean that the focus is at 3, if I go down 5, so this is going to be 3, negative 3. Yeah, 3, negative 3. So let's go ahead and write those down. So the focus is going to be at 3, negative 3, which kind of makes sense because if we were at 2 for the vertex and we went down 5, that would get us at negative 3. And the directrix is going to come up here. It's going to be a horizontal line, so that's going to be y equals 7. And then the length of the lattice rectum, again, we don't have to graph this or anything. It literally is just this number right here. So the length of the lattice rectum is 20. Okay, so I think we got all the information on that one. So I'm going to slide down here and let's take a look at the very last one. You can probably guess what it's going to be just because we've done an ellipse and a parabola. You can probably guess what this one's going to be. And we can confirm that by taking a look at the equation. Notice that the squared variables are on the same side, and all we have to verify is that they do have different signs. We've got a negative x squared, we've got a positive y squared. So this is going to be a hyperbola. Okay, so we got our work cut out for us. We got a whole bunch of these things, but we can eliminate a few. There's no lattice rectum, so we're going to put an NA on that. It does not have a major axis. We'll put an NA on that. Direction of opening we're going to need to have, and it does not have a directrix, but it's got everything else. So let's see what we get here. So we just need to be careful. So I'm going to, now because this is the positive one, I'm going to write this as 4y squared minus 16y, so we get those in the right place. And then over on, we're going to save room to complete the square, and then we've got a minus x squared minus 8x. And I've got those taken care of. I'm going to move the 100 to the other side, so that's going to be a plus 100 over there. Okay, and then I need to factor both of these, so I need a 4y squared minus 4y. I'm going to take out just the negative here, so this is going to be an x squared plus 8x. Whoops, make that look like an x. And then save room to complete the square, so then there's 100 over there. Okay, then we're going to go ahead and complete the square. So I take half of this, that's a negative 2. I'm going to keep that because I'm going to use it in just a second. I square that, I end up with a 4, but by multiplying here, what I really did is I added 16 here. So I'm going to put a plus 16 over there. And then I come to this one, I take half of this, that's going to be a 4. I square that, so that's going to be 16 in here. But by multiplying that by the negative on the outside, what I really did is I subtracted 16. So I'm going to put a minus 16 on this side. So the cool part about this is the two of those cancel out. We've still got 100 on the other side, and let's write down what we've got here. This is going to be a 4 parentheses y minus 2 quantity squared. Okay, then minus, this is going to be x plus 4, whoops, x plus 4 quantity squared, and then over here we've got 100. So we've seen something kind of like this before. Let's go ahead and divide everything by 100. And here's what we have. We have y minus 2 quantity squared over 25 minus, this is going to be x plus 4 quantity squared over 100. Nothing changes there, and then we've got the 1. So this is the right formula. This is the right equation in a nice graph-friendly form. And from there, we can identify the center. So the center on this is going to be opposite of whatever's with the x, so this is going to be a negative 4, opposite of whatever's with the y, so this is going to be a 2. So the center is going to be at negative 4 comma 2, so I'll go ahead and mark that down. Okay, and the fact that this is a positive y means it opens in the vertical direction. Okay, so let me get a kind of a sketch going here. So we're at negative 4, so we're going to go back 4 and then up 2, so about right there. There's the center, so I'll just mark that. And then in the y direction, we're going to go, so that's positive, we're going to go 5 units up here, okay? So that means I've got a vertex here and a vertex here. So the x-coordinate isn't going to change, so that's going to stay negative 4, but we're going to go up 5 units, so that's going to put us at 7, and we're going to go negative 4 for the x-coordinate. We're going to go down 5 from here, so that's going to put us at negative 3. So let's go ahead and mark those. Those are the vertices, okay? And remember, it's opening up and down, which we can mark right here. So opening up and down, or you could save yourself a little bit of time by just saying opens vertically, okay? And then our vertices are, so we've got one at negative 4 comma 7, and we've got another one at negative 4 comma negative 3. Let's go ahead and do the asymptotes while we're at it, because this is just going to be whatever's with the y, so y minus 2. Okay, and then a plus or minus, and then whatever's with the x, so that's going to be an x plus 4. And then the fraction is going to be whatever's in the vertical direction, so that's going to be 5. Square root of whatever's in the horizontal direction, so that's going to be 10. So we can simplify that, 5 over 10, this would end up being 1/2. Okay, so we got a 1/2 there. And then the only other thing that we need to worry about is going to be the foci. Well, the foci are going to be inside the curved part of the conic section, so they're going to have the same x-coordinate, we're just changing the y-coordinate. So this is going to be negative 4 comma something, and I'm going to save some space for that, and negative 4 comma something. Okay, and we just need to figure out how far we're going to go. Well, remember, it's going to be the two of these added together, so it's the a squared plus b squared equals c squared. So this is going to be 25 plus 100 equals c squared. So that means we've got 125 for c squared, so that means we're going to take the square root. So square root of 125 is 5 5s, So this is going to be 5 radical 5. So that means we're going to start wherever the center is. So we're going to start at 2, and then we're going to add 5 radical 5, and we're going to subtract 5 radical 5. So this is going to be 2 plus 5 radical 5, and this is going to be 2 minus 5 radical 5. Okay, now if drawing a better sketch is helpful for you, that's totally okay. You're welcome to do that. But I think we've got this all done. So just make sure that you're paying attention to details. Mark NA for things that don't apply. And there you go. Good luck on the test.